This poster title is Separation of the Collar Pin from Collar Pa Racemose by using the simulated moving bed. Introduction. Collar pops such as sea grape or racemose is rich in collarpin. The literature points out that this substance has anti-inflammatory, anti-tumor, anti-tuberculosis, and plant growth regulation functions. Separation of collarpin by traditional methods, such as large silica gel column or high-speed countercurrent chromatography separation technology, often requires more types of solvents, difficult selection, solvent toxicity, pollution, and solvent recovery problems. The simulated moving bed is a continuous separation and purification device, which is very suitable for the separation of two components. It has the advantages of less solvents, low solvent toxicity, rapid separation, and large yield. Therefore, the collarpin in CollarPa is very suitable for separation and purification in a simulated moving bed. Experimental design. Here is an explanation of SMB operation settings and HPLC analysis conditions. Simulated moving bed chromatography is to simulate the reverse contact between the stationary phase and the mobile phase by periodically changing the positions of the feed and eluent inlets and the outlets of each product. The simulated moving bed used in this research is a 3-section open-loop design, and its configuration is abbreviated as 2 halves, as shown in Figure 1. There are 2 inlets in the figure, and the feed, the desorbent, as well as 2 outlets, extract and raffinate. SMB conditions. The column size is ID 10 mm by 250 mm, and the packing is Welch Ultimate AQC 18. Desorbent 7.5 ml per minute. Feed 0.3 ml per minute. Extract 4.4 ml per minute. Raffinate 3.4 ml per minute. HPCL conditions. Mobile phase gradient ethanol from 10% to 90%, and time from 0 minutes to 15 minutes. Flow rate 0.75 ml per minute. Column Phenomenix Luna C18 5 micrometers 4.6 mm times 250 mm. Temperature 25. Wavelength 315 nanometers. Results and discussion. The simulated moving bed is mainly based on the following principle. When a feed containing 2 components of AB is injected after a solid adsorbent that simulates a leftward flow, the 2 substances are eluted by a move-in phase flowing from left to right, which has strong retention. The B will be taken to the left by the solid adsorbent, and the weakly retained A will move to the right with a mobile phase. With this feature, the solid adsorbent in each block can be used most efficiently to achieve the goal of continuous sampling, as shown in Figure 1. The simulated moving bed uses many switching valves to perform switching control between the blocks, thereby achieving the effect of the simulated solid adsorbent and the mobile phase countercurrent, resulting in the separation of solutes with different retention strengths. Therefore, if you want to separate A and B, the key theory, triangular theory, of simulating a moving bed is very important. Triangle theory is an important theory in the TMB mathematical model. It can be used to simulate the flow rate setting of the moving bed and the estimation of the string switching time. To complete the mathematical model of the triangle theory, you must first complete the simulation of the pores of the pipe string in the moving bed. The adsorption of Henry's constants Ka and Kb on the stationary phase, and isothermal adsorption of substances A and B according to the experimental results of a single string, as shown in Figure 2. The porosity is 0.296, and Henry's constant value of the Ka and Kb are 0.545 and 0.860, respectively. According to the values of porosity and Henry's constant, triangle theory can be used to simulate the operating conditions of the moving bed experiment. The set flow conditions are: desorbent 7.5 milliliters per minute, feed 0.3 milliliters per minute, extract 4.4 milliliters per minute, raffinate 3.4 milliliters per minute. The switching time is 3.5, 4.5, 5 and 5.5 minutes respectively, as shown in Figure 3. According to the experimental results, as shown in Figure 4, when the switching time is gradually changed from 3 minutes and 15 seconds to 4 minutes and 30 seconds, the impurities in the extraction end gradually decrease, but when the switching time is 4 minutes and 30 seconds, part of the pteridophyte began to appear, brought to the extraction end. The wavefront of the pteridophyte at the extraction end began to shrink. If the switching time is shortened to 4 minutes and 15 seconds, most of the phycoerythrin is desorbed from the extraction end, and other impurities in the sea grape begin to elute from the raffinate end. The solution at the extraction end is analyzed. The purity of red pigment is 96%. So 4 minutes and 15 seconds is the best switching time for the simulated moving bed. Conclusion: using ID 10 mm by 250 mm, the filler is Welch Ultimate AQC18. When used as a simulated moving bed separation column, the flow rate is respectively desorbent 7.5 milliliters per minute, feed 0.3 milliliters per minute, extract 4.4 milliliters per minute, raffinate 3.4 milliliters per minute. The switching time is 4 minutes and 15 seconds. This is the optimal operating condition, and the purity of pterophyrin can reach about 96%.